Good afternoon, everyone. We are here today to talk to Dr. Shuvo Roy and learn a lot about what he's currently working on. And he is a member of the Home Dialyzers United Professional Board, and we are excited to chat with him today. Dr. Roy, thank you so much for joining us today. Um, I guess my first question it would be just for our audience to get a little bit of information about you, who you are. It's just to talk a little bit about your career, what you have, what you're doing, and what you're working on.
Yeah. Well, first of all, John, it's a pleasure to be with you and finally see you in person. I am Shuvo Roy. I'm a professor in bioengineering at the University of California, San Francisco, and I'm also the technical director of the Kidney Project. What our main mission is to build an implantable bioartificial kidney to provide the benefits of transplant to the people who are currently on dialysis and may not get a transplant.
Okay.
That's our big vision. And I got to this point not by being a nephrologist, and I'm not a nephrologist, I'm an engineer. I went to graduate school to work on electrical engineering and semiconductor electronics. When I finished that, I ended up going to work in biomedical products and ran into a nephrologist who said, perhaps you can use your electrical engineering knowledge and of especially sensor technology and electronics design to make a better dialysis machine. And that led to additional discussions where he said, maybe we can actually go beyond dialysis ultimately and get to something that's a totally implanted artificial kidney. And that's how I've ended up what I'm doing today in San Francisco at the University of California.
Awesome. That's exciting. I know that those of us who have received transplants and who have done dialysis as well are very excited about that potential opportunity. Can you tell us a little bit more about the project itself and where you're at and how do you see it moving forward?
The goal of the Kidney Project is to provide a device that is totally implanted and can provide the benefits of a kidney transplant to those dialysis patients that are unlikely to get one. So what do I mean by that? It's basically a device that provides both the filtration capacity of a healthy kidney, combine them with all the metabolic functions of a healthy kidney into something the size of your fist that is surgically implanted like a transplant, and then connected to the bladder, and then you're able to walk about, eat and drink freely, travel, feel good about yourself both physically and mentally, and it functions for all intents and purposes like a kidney transplant for those people who are maybe not lucky enough to get a transplant because of their shortage.
Awesome. So whereabouts are you in the project?
Yeah, so we have actually shown that the concept works. I'm here today at the American Society of Nephrology 2022 Kidney Week meeting, where we presented for the first time the combination of our filter unit with a cell therapy unit into a single device that was put into a large animal, pig, connected to the bladder and blood vessels, and we showed we could produce urine without immune suppression drugs, without blood thinning drugs, and the pig did not show any adverse effects. So we are at a preclinical stage, but we are showing the functional prototype. I'm very excited about this because it shows the concept of a filter coupled with cell therapy in an artificial device can be implanted and make urine.
That is amazing. That is really, really amazing. Because I know as a transplantee myself, and with the full reality of knowing that you never know how long your transplant's going to last, having to look forward to that potential option is definitely, a ray of sunshine. So, as opposed to just once going back onto dialysis. So I do have a kind of a little side question because I know that I've been curious and I know that other people I've spoken with have been curious as well. I know that you said that you had, you implanted a pig. And we recently heard about the work that was being done with the pig not too long ago in the realm of transplant as well. So why the pig?
Yeah, That's a great question. Why are we using pig as our model, to use science speak? Because the pig's anatomy and pig's physiology is very close to that of a human. The type of urine it makes, the type of blood chemistry it has, the size, the blood flow rates are very similar. That's why pigs have become a baseline animal model for testing out these concepts. And what is also very interesting, and we have to keep in mind, is whenever we do science, we have to eventually get to human. That's our goal. But if you do a pig, you can actually go from a pig to a human. And that's what the people who did the xenotransplant did. They tested in a pig, and they showed safety in a pig, then they were able to do this in a brain-dead human patient. Many other technologies first get tested in a mouse, but then it has to be re-engineered for a human. This one, once you develop it for a pig, is more or less developed for a human.
Okay. My mind is blown. So I guess my next question is going to be, what are the next steps for the project? Where do you need to go? What do you need with regards to getting it to the finish line?
So thank you for that question. I think one of the things we should first probably give you a little insight is how the device actually works. I've sort of given you that there's a filter component and a cell therapy component. So the filter component is constructed from semiconductor silicon, which was my training in engineering. We couple that with cell therapy. We call it the bioreactor, which is taking the state of the art in cell biology, specifically kidney cells, and putting them into a device. And then the two are put together in tandem to work very much like our native kidneys, where you filter blood first, you generate a lot of filtrate and toxins, then the tubule in our native kidney and the bioreactor in our device processes that filtrate and concentrates the toxins into urine. And what I showed in this meeting is that we can actually produce urine. What I should be clear about is that we produced very little amounts of urine because the amount of cells we had and the amount of filter area had was very tiny in compared to what we need for a human.
All right.
Okay, so the question is, how do you get to a human? We did a prototype for the animal to show that we can produce urine. I should also be clear, the animal itself was not sick from kidney failure. It was a healthy kidney, so the animal could be alive. So we now need to make the device have the capacity so that it can provide enough urine output. How do we do that? We have to increase the filter area. We have to increase the amount of cells.
All right.
That sounds simple, and it is in some ways, but it's difficult in that we have to go through an engineering exercise to make a lot of filters and a lot of cells. And that has to involve commercial partners that understand manufacturing, that understand quality control, that understand packaging. And once we've done that, then we've got a clinical grade device. So that's the next big step.
All right.
And once we get the clinical grade device, then we can think beyond that to the first in human.
Okay. So I believe I got that. And it's extremely fascinating. I know that our audience is going to find that very exciting as well. And they're going to have a ton of questions too. So with that said, how do people get in touch with you? How do you want them to connect with you? And of course, we'll take this information and incorporate it into, the post link and so forth. But how do you want them to reach out to you?
Sure. Thank you for that question, John. We love for people to contact us. We're on social media at The Kidney Project, Twitter, Instagram, Facebook, YouTube. We are all on there. You can also email me at shuvo.roy@ucsf.edu. But if you want to follow the status of the project and know what needs to be done or what is happening, please follow us on social media.
All right.
And join our journey. Our journey is supported by us learning from you as patients, you as other scientists, you as the public, you as people who wanted to get their treatments done at home, as well as we hope to educate you to make sure you understand what the opportunity is, but also what the challenges we must overcome.
Okay.
And it's going to require a team effort to get over the finish line. But once we get over the finish line, we are going to have something that transforms treatment for kidney failure in a way that has not been done before.
Amazing. Well, Dr. Roy, thank you so much for being with us today. I know that I'm excited. I know that Home Dialysis United is excited. And our audience, I know, is going to be amazed about with regard to the work that you're working on, and are going to be asking many questions. Again, thank you so much for being with us today.